All right, a few more moons of the solar system we're going to talk about. We're going to jump out to Uranus now. And Uranus' most interesting moon is Miranda. Miranda is really just a chunk of rock and ice. And what makes it interesting is the weird terrain you see. You see, this looks like normal, if you look at the bottom here, this looks like normal moon terrain. That's what you would expect. Impact craters, kind of rough over billions of years. But you have weird stuff like that. Here's a right angle. First of all, you hardly ever see a right angle in nature. It just doesn't happen. And then you have this bizarre, weird terrain up here. So the whole thing looks kind of weird. Let me show you some more pictures here. This is a closer up view of this weird terrain. This is like normal stuff. Then you have this weird stuff here. There is a really giant cliff here. Cliff that's like thousands of feet tall. All right, several thousand, many thousands of feet. If you jumped off of it, it would take you like 20 minutes to hit the bottom. Now there's no air or atmosphere, so you couldn't use a parachute. You would accelerate all the way till you hit. But it would take you a long time because the gravity is really low and it's such a high cliff. Why would you have this bizarre terrain? Well, what we think happened is that Miranda got struck by something large, like another moon or a very large impact, and it broke it into chunks. Okay? So some large object came and hit it, broke it into chunks, but then these chunks were still in orbit, so over time they came back together again. But when it breaks apart, some of the chunks might get spun around and come in, so the parts that were on the inside ended up on the outside, and parts on the outside just still stayed on the outside, and parts of it didn't come together and match up very well, which is why you had this giant cliff. So all these chunks of material came back together to form Miranda, reform it, but it didn't put it in the same pattern that it was before. So a very interesting moon just from a geological point of view. All right, so that was the only one that we're interested in, Uranus. The rest are pretty normal. Let's talk about Neptune. Neptune's most interesting moon is Triton. Don't get confused between Titan, which is the moon of Saturn, and Triton, which is the moon of Neptune. First of all, Triton is a very large moon. It's several thousand kilometers across. All right, so it's one of the bigger ones. And it is the only large moon with a retrograde orbit. What does that mean? It means it's going backwards. All the other major moons, now there's a lot of tiny ones, especially around Jupiter. Most of Jupiter's moons of its 60 are like captured asteroids that got too close and they chunks and they go in weird directions. But all its major moons all go counterclockwise. All the major moons of Saturn go counterclockwise. The rings of Saturn all orbit counterclockwise, right? Because the cloud that it's spinning from, the moons were probably formed at the same time what the planets were, was all spinning counterclockwise. Okay? But not Triton. Triton is weird because we have Neptune, and Triton is going around. Instead of going counterclockwise, it's going clockwise. But the other moons of Jupiter, are going counterclockwise. I mean Jupiter. Of Neptune are going counterclockwise. So all the other moons are going counterclockwise, but we got one going the wrong way. Thing about it going the wrong way is it's one of the big moons of Neptune too. Also, you see, this is what it looked like when Voyager 2 shot pictures of it. This up here is called the cantaloupe terrain. It looks kind of like the surface of a cantaloupe. And then it has this polar ice cap. Now this polar ice cap is made of nitrogen ice. Remember we talked about nitrogen ice on Pluto. You're so far away from the sun, there's almost no solar radiation getting there. And so it's so cold that nitrogen just freezes on the ground and creates this ice down here. It kind of has a pinkish color to it. Also, if you look close, you see these black marks. You're like, well, what creates those black marks? Let's see, I think I have a closer picture. Well, I'll get to it. First of all, you look at that really close right there. Those are clouds. If you have clouds, you have to have an atmosphere. So Triton has an atmosphere. It's super thin. It's like 1/10,000th atmospheric pressure of the Earth. Very, very thin, but it does have a slight atmosphere of nitrogen. And then it's cold enough at the poles, the nitrogen just freezes onto the ground. Okay? Here is a closer up view where you can see these black streaks, and they're all going the same direction. So what Triton has, it has geysers too. So it's the third one that has geysers, but the geysers are of liquid nitrogen. So below the surface you have liquid nitrogen. Remember, it's warm down here from tidal heating. Okay, it heats it up and all the material flows out. Now the difference is, because Triton has an atmosphere, it has wind. The air is moving, and so the air blows all the material. So we got a wind going this way, and all the material falls down to the surface. But instead of making a nice, perfectly circular pattern like we see on Io and Enceladus, because there's no wind, there's no atmosphere, there's an atmosphere that pushes in one direction, so you can see it creates these tails, these black tails. So we know that the wind is blowing this way on this part of Triton, and that all these, every one of these little black spots, is a geyser of liquid nitrogen. So we have 3 moons in the solar system that have these kind of active geysers on them. Alright, and that's it for the moons of the solar system that you need to know.